We all know AI is fundamentally changing our world, right?
Yeah, absolutely everywhere.
But the really big question is, who gets to control that transformation? Who holds the keys,
Hmm.
That question seems to be pushing nations towards something called sovereign AI.
And that's exactly what we're diving into today. Our goal here is really to cut through the noise, pull out the critical insights, maybe find some surprising facts.
Yeah, and help you get informed quickly on this, because it's moving fast.
It really is.
So, sovereign AI, at its core, what is it? From what we're seeing, it sounds like a nation having complete control over the entire AI stack.
That's the idea. The physical infrastructure,
Hmm.
the data centers, the actual compute power, the networking.
The hardware backbone.
Right. But it's much more than just the hardware. It's also control over the data itself, how it's collected, processed, governed.
Keeping it inside borders, ideally.
Yeah, exactly. Keeping it secure.
Huh.
And then it's about the algorithms, developing the models, the frameworks, the applications that fit that nation's needs.
And the people, too, right? The talent.
Oh, absolutely critical. Cultivating the talent pool, the researchers, the engineers, the operators who can actually build and, wield this tech.
So you could almost think of it like technological self-determination, but for the AI era.
That's a good way to put it. And the sources make it really clear this isn't just some, technical wish list. It's deeply strategic.
How so?
Well, it's seen as essential for preserving, say, cultural and linguistic identity, developing AI systems that actually understand local contexts.
Okay, that makes sense.
Yeah, and it's fundamental for data sovereignty, keeping sensitive citizen data protected at home, crucial for fostering economic growth through homegrown innovation.
National security implications, too, I imagine.
Huge. National security, geopolitical leverage. This isn't just about using AI. It's about weaving it into the very fabric of a nation's society, its governance, its resilience.
So yeah, this isn't just theory. It's actually sparking a global race.
Definitely. The sources paint this picture of a profound shift happening right now. Countries are intensely competing, not just for economic edge, but for, strategic positioning, leadership in this new AI world order.
And the money involved, the investment picture really shows the scale of the challenge for some.
Oh, yeah. There's a massive disparity in global private AI investment. The data we looked at, the U.S. is just overwhelmingly dominant.
How dumb.
Between 2013 and 2024, cumulative private investment in the U.S. hit, get this, $470.9 billion.
Wow. Okay. Billion with a B.
Right. And in 2024 alone, it was $109.1 billion.
That's just colossal, especially when you compare it to others.
Exactly. China, for instance, saw $9.1 billion in private investment in 2024. Still huge, but nowhere near the U.S. level.
And India, they're talked about a lot.
India's growing fast, yeah. They attracted $1.16 billion in 2024, and cumulatively about $11.1 billion from 2013 to 2024.
So what these numbers really scream isn't just economic difference, it's a strategic chasm, isn't it?
It really is. The U.S. isn't just leading, it's creating this kind of gravitational pull. It shapes the whole global AI landscape, and it forces other nations into, fundamentally different strategies.
And you see that reflected in their national plans. Yeah.
Absolutely. The U.S. approach, it's described as forward-leaning pro-innovation. Lots of R&D funding, especially for national security.
I read something about coal power.
Yeah, interestingly, some sources mention discussions in certain U.S. states about potentially using coal-powered infrastructure specifically to meet the huge energy needs of new data centers.
Right. Meanwhile, China's got this ambitious goal. It lead the world in AI by 2030.
Yeah, declared goal. And they're backing it with state funds. There's one fund, about $8.2 billion, just for early-stage projects. Big focus on indigenous models like DeepSeek.
And the EU.
The EU is also aiming for leadership by 2030. Talking substantial investment, maybe $200 billion across the whole AI value chain, a key focus for them. Building enough infrastructure to cut down dependency on foreign providers.
Canada's in the mix, too.
Yep, Canada's investing heavily in domestic compute, public supercomputing. $1 billion federal investment there. Japan's focusing on strategic partnerships, notably with NVIDIA, for instance.
And India, again, with their India AI mission.
Right, about $1.2 billion over 5 years, specifically for infrastructure, even targeting homegrown GPU development. They've got a government-funded LLM called FaratGen for public services, and this AI-ready data initiative. It's a big push for self-reliance.
And the UAE, they seem to be making a big play.
A major play. Aiming to be a top AI hub by 2031, they're projecting something like $96 billion contribution from AI to their GDP by 2030. Massive numbers.
Okay, so across the board, one common thing seems to be these public-private partnerships.
Yeah, that's a definite threat. Governments, industry, academia, all trying to work together to speed things up. You're going to have to.
Which brings us down to the absolute physical reality, the infrastructure, the
Yeah.
energy.
Exactly. Data centers, they are the factories of this AI age, right? Housing those essential GPUs.
And scale of that infrastructure.
It's growing fast. Global data center capacity was around 59 gigawatts in 2023, projected to more than double, maybe 122 gigawatts by 2030.
But that global number hides big differences, doesn't it?
Huge differences. The sources point out, for example, the U.S. has something like 21 times more data center capacity than India.
21 times, wow.
Yeah. And the specialized hardware, those high-end GPUs, they're indispensable. But access is highly concentrated. Wealthy nations, a few giant tech corporations.
So compute access becomes strategic, like a currency in this race.
Absolutely. And here's where it gets, well, really interesting. The energy demands, they're just immense.
How immense?
AI workloads are a primary driver pushing up data center power use. It's projected to increase global data center power demand by a staggering 165% by 2030.
165%.
Yep. And AI workloads alone were 14% of global data center power in 2023, projected to hit 27% by 2027.
That scale is hard to grasp. I heard a comparison, like one AI data center uses as much power as...
Yeah, 100,000 households. That's a common estimate, yeah.
And Goldman Sachs, they projected.
Right, they projected AI data centers will need an additional 200 terawatt hours annually by 2030.
Which could be...
potentially 30% of all global data center power consumption by then.
Okay, so the big question the sources raise is, can the grid even keep up?
Exactly. Can it possibly keep up without massive, rapid investment? And like we mentioned, it's pushing some places, like parts of the U.S., to even look at coal power again, just to meet this skyrocketing need.
Which fundamentally changes things. Energy supply, grid stability. They're not just utility issues now, they're geopolitical assets.
Totally intertwined.
Yep.
Energy sovereignty is now directly linked to AI sovereignty.
And the environmental impact. Can't ignore that.
No way. Training these huge models emits, thousands of tons of carbon. That's a major driver for innovation in what people are calling green computing. It has to be.
Stepping back a bit, the sources also really hammer home how AI is reshaping geopolitics itself. These technologies are becoming tools of power, of control.
A prime example, those U.S. export restrictions on advanced chips.
Right, the GPU bans targeting China.
Exactly. High-end NVIDIA GPUs mainly.
Yeah.
The stated goal is pretty explicit. Maintain U.S. tech leadership and address national security concerns.
Which chips specifically?
Advanced ones like the H100, H200, the new Blackwell chips. And as of April 2025, they even extended it to the slightly less advanced H20 chip.
Why the H20?
Citing its potential use in supercomputers for military applications, according to the sources.
And that obviously hits companies like NVIDIA hard.
Big time. They anticipated charges like $5.5 billion in just one quarter from the H20 restrictions for China alone, and their China revenue share already dropped significantly from about 26% in 2022 down to an estimated 13% in fiscal 2025.
But here's the twist, right? The effect on China might be counterintuitive.
Yeah, it's fascinating. The sources suggest these controls are paradoxically maybe accelerating China's own push for self-sufficiency in semiconductors.
How so?
Well, as one source put it, scarcity fosters innovation. Locking access can actually accelerate China's efforts to build their own stuff.
Which has wider ripple effects.
Absolutely. Potential long-term revenue losses for U.S. firms, risk of isolating U.S. tech from a huge market, and potentially opening doors for Chinese competitors down the line.
And it's not just China affected by these rules.
No, it hits many other countries. The U.S. rule classifies nations into tiers. Tier 2 nations face strict limits on GPU imports, and Tier 3 nations face outright bans. It really restricts their options.
And then there's the military side. AI isn't just making things faster, it's changing warfare itself.
Fundamentally changing it. And this is a huge reason why nations see national control as, well, an existential security concern.
So the U.S. military?
Scaling up AI integration significantly, sources cite this almost 1,200% increase in Pentagon spending on AI contracts just from 2022 to 2023.
Wow. Any specific projects mentioned?
Yeah, things like Project Thunderforge for military planning, autonomous warships like the Sea Hunter, Project Maven for intelligence analysis.
And China's approach?
They call it intelligentized AI warfare. Basically, integrating AI across everything: psychological ops, behavioral analysis, social media stuff, automated intelligence, real-time tactics.
Yeah,
It works.
Israel, too, right? Deep links with tech company.
Yeah, deep integration, major tech companies providing AI services. It just underscores why nations view AI capabilities and controlling them as absolutely critical for strategic advantage and security.
Okay, so we see the potential, the race, the strategic importance. But what about developing countries? Gene AI offers huge promise, right? Healthcare, agriculture, education.
Immense potential, absolutely. But the sources are really clear. There are significant barriers preventing them from easily realizing that potential.
Starting with the basics, like infrastructure.
Yeah, the fundamental bottleneck. The digital divide is still massive. You've got 2.6 billion people, like a third of the world still offline.
And the difference between rich and poor countries.
Stark. Internet penetration is only about 27% in low-income countries. Compare that to 93% in high-income ones.
That's the digital canyon I've heard about.
Exactly. It impacts everything. Basic connectivity, a kid's ability to access online education, reliable internet, access to devices, it's just not universal.
And then the compute power issue we talked about, data centers.
Hits developing countries particularly hard. That dependency on high-end GPUs, resources are just so concentrated. Latin America and the Caribbean, only 4.8% of global data center infrastructure. Asia Pacific, just 26% of hyperscale capacity.
So if you don't have your own data centers,
you rely on foreign ones, which means your data, your AI systems, they're subject to foreign rules, foreign regulations. That directly undermines any goal of sovereign AI.
And the energy problem hits them harder too, I bet.
Definitely. That energy AI paradox. AI needs tons of energy and water, but many developing regions are already struggling with unreliable grids, water scarcity.
So scaling AI could actually make things worse.
It easily could exacerbate existing crises or force them to rely on, say, carbon-intensive energy sources just to power the AI, which then works against climate goals.
So for them, green computing isn't just a nice idea.
It's an economic necessity. If they want to build sustainable AI capacity, they have to figure out the energy piece efficiently.
And then there's the money, investment barriers, the capital chasm, as one source called it.
Yeah, that's stark difference again. Over $100 billion private AI investment in the U.S. last year, just over $1 billion in India. It highlights the gap.
Where does the venture capital usually go?
Heavily concentrated in high-income nations. And the cost of just training a big generative AI model from scratch, it's astronomical.
Like those numbers, $78 million for GPT-4 training, $191 million for Llama 3.1.
Right. Those kinds of costs basically put building truly sovereign foundational models out of reach for most nations.
So they need foreign investment, but that creates its own problems.
Exactly. It's crucial, but there's tension. Sources mention worries about digital colonialism, economic rent-seeking by dominant foreign firms.
Like foreign investment becoming a strategic tool.
Potentially, yeah, in a geopolitical battlefield, as some frame it. And there's a risk that local innovations just get squeezed out of the market.
Plus those GPU export rules hit them too.
Right. The U.S. rules effective Jan 2025, restricting sales to over 100 countries, strict limits for Tier 2, bans for Tier 3. It can force these nations to just import AI models and services from Tier I countries instead of building their own capacity.
And finally, even if you have the tech, making it relevant locally, that's another hurdle. Language, culture.
Huge challenge. LLMs are trained mostly on English, maybe a few other major languages. So less used languages. The sources mention Ahirani, the shortest script risk being digitally marginalized, maybe even wiped off the planet in the digital sense.
And the models can just get things wrong.
Yeah, they can hallucinate, flatten out the richness of a language, struggle with local accents, produce content that's culturally tone-deaf, or worse.
Because they reflect the culture they were trained on.
Exactly, embedding biases from dominant cultures.
Yeah.
So you have this tension. The local innovation imperative, needing AI solutions tailored for local problems in farming or health.
Versus the global template trap, just adopting whatever's available globally, even if it doesn't really fit.
Right. And layered on top of all that is a severe talent gap. Brain drain pulls AI experts towards countries with more resources.
Making it even harder to build local self-reliant capabilities.
Okay, so that sounds pretty challenging. A lot of hurdles.
It is. But despite all that, the sources also reveal something pretty hopeful. There are these innovative strategies emerging. Alternative pathways.
Pathways that don't require billions in capital.
Exactly. Ways to achieve practical AI outcomes with much lower outlay. Moving beyond that hardware-first approach that only the richest can play, it's about, well, doing more with less.
Okay, I'm listening. How does that work?
Well, first, big one. You don't necessarily have to reinvent the wheel. You can leverage existing open model.
Like Llama Falcon?
And
Well,
using those as a base initialization saves that astronomical cost of training a huge foundational model from scratch. Remember that Stanford alpaca example?
vaguely. Remind me.
They managed to basically distill ChatGPT-like capabilities into a small 7 billion parameter model for around $600.
$600? How?
Just by using API calls to get data for fine-tuning, it shows the power of building on existing work.
And that immediately helps with local adaptation, right?
Exactly. Enables adapting for local languages, local contexts, like the UAE's Falcon model, or using Bloom for low-resource languages.
Okay, so leveraging open models is step one. What else?
Then there's a whole set of techniques under the umbrella of parameter-efficient fine-tuning, PEFT. These are kind of game changers. Techniques like LoRa, QLoRa, DORA. Instead of retraining the whole massive model,
You just tweak a small part.
a tiny fraction, often less than 5% of the parameters. LoRa, for instance, it quantizes the model, uses less data per parameter, which lets you fine-tune a huge 65 billion parameter model on just one GPU with 48 GB of memory.
Okay, that's huge. That really democratizes access, doesn't it?
Totally. LoRa alone can cut the memory and compute needed for fine-tuning by up to 70%.
So PET is key. Any other tricks?
Regionalization via adapters. Think of it like plugins. You train small modules adapters on local language or specific domain data.
And then just add them to a bigger model.
Yep, plug them into a larger, globally trained base model. It adds the regional specifics without retraining everything, much cheaper, and it avoids the model forgetting its general knowledge.
What about combining models?
Yeah, model merging or strategic selection.
Yeah.
You could use several smaller, specialized models and route queries to the best one. Or merge models trained on different things, like DeepSeek merged code and language models. Get strong results without one giant model.
And keeping models updated.
Continuous pre-training. Take an existing model, keep feeding it new, local data to keep it current or specialize it without the full cost of starting over.
Okay, so that's making development cheaper. What about actually running the model's inference? That still takes compute, right?
It does, but there are ways to make inference much more efficient, too. New model architectures are a big part of it.
Like what?
Things like BitNet uses 1-bit weights, apparently can run a 100 billion parameter model on a single CPU using way less energy.
100 billion on a CPU.
Yeah.
Yeah.
Or Mamba uses a different mechanism than attention, better for long sequences. Efficient attention techniques make attention linear, good for low bandwidth, even multiplication-free attention, using cheaper CPU operations.
Lots of innovation in the architecture itself.
Showing like 5x, 10x gains in speed or energy reduction. Then there's split inferencing.
Splitting the work between the device and the cloud.
Exactly. Reduces server load, keeps sensitive stuff maybe on a local device for privacy, balances the compute. Split LLM is one example, getting good quality with only like 25% of the compute.
Collaborative decoding. What's that?
Having multiple models work together during generation. Speculative decoding is a big one. A small, fast model generates a draft, and a bigger model just quickly verifies it.
Speeding things up without losing quality.
Right. Gives like a 2-3x speed up. Google uses it in production. EGLE, Medusa are similar ideas.
Or you could use a small model mostly, and a big one just for checking.
Yeah. Use a small language model, an SLM, maybe 100 million to 7 billion parameters for most of the work. The big LLM only steps in occasionally to verify or correct, gives you near LLM quality at a tiny fraction of the cost.
What about pooling resources?
Distributed or federated inference. Projects like Petals use volunteer computing people lending their GPU time for LLMs. Federated learning trains across decentralized data while preserving privacy. Lets you scale out using more standard hardware.
And back to those small language models, the SLMs, they seem really practical.
Hugely practical. They need drastically fewer resources, often run on a single decent GPU, maybe even a CPU if you quantize them.
And they can be good enough?
Crucially, yes. Fine-tuned SLMs can often match or even beat much larger models on specific specialized tasks. Think models like Llama 2.7b, Tiny Llama, Bloom 3b. And the key is PEFT makes fine-tuning these accessible SLMs feasible on minimal hardware, like maybe even a laptop.
Okay, one last area mentioned was test time scaling, making models think more.
Yeah, this is fascinating. You don't change the model's weights, you just make it work harder during inference. Self-consistency is one way.
Generate multiple answers and pick the best.
Right. Have the model generate several possible answers and then choose the most consistent one. A 2.7 billion parameter model doing this can apparently match the reasoning of a 6 billion model that doesn't.
Interesting. Or iterative refinement.
Yeah, where the model is prompted to refine its own output. Studies show that spending extra compute per query this way can let a smaller model outperform models 14 times larger.
So thinking longer can substitute for thinking bigger.
Exactly. Dynamic adapters also fit here, activating specific modules at inference time for different skills, but with the efficiency of a small model. This whole think more idea shifts focus from just making models bigger to making the computation per query smarter. It's a potential equalizer.
So all these strategies,
Mm-hmm.
they really offer a different path for nations without huge resources.
That's the takeaway. They help build in-house capabilities, create more diverse tech stacks, reduce dependency risk. It's about building national model repositories, curating relevant local data sets, developing open source tools like India's Bashini initiative for language tech, building resilient ecosystems without needing massive upfront capital.
Wow, okay. That was quite the deep dive. We've really unpacked a lot there. The intense global race, the huge infrastructure and energy needs.
Yeah, the geopolitical power plays, how AI ties being used as a tool, and those significant hurdles for developing countries trying to catch up.
Absolutely. But I think what really stands out, especially from that last part, is that the sources show there are powerful alternatives, often open source.
Right. These strategies for efficient development, clever adaptation, low-cost inference, they mean nations can potentially achieve powerful AI outcomes by, well, doing more with less. It's not entirely hopeless if you're not the US or China.
It's such a complex picture, though, isn't it? Multi-layered. And right at the heart of it, you have this fundamental tension. On one hand, AI's incredible potential for global collaboration, open science, shared progress.
But on the other hand, that strategic imperative. National sovereign AI, driving countries towards self-sufficiency, control, maybe even isolation in this critical tech.
Exactly. That tension is fundamental, and it's going to shape everything about AI development, deployment, access worldwide for years to come.
So for you, our listener, maybe a final thought to chew on as you digest all this.
Yeah. How will nations, especially those maybe with fewer resources, actually navigate this? How do you balance the benefits of being part of a global AI ecosystem using open research, open tech?
With that strategic need, as they see it, to build their own strong domestic capabilities.
And what does the rise of all these efficient, low-cost AI techniques really mean for shifting the balance of power in this global AI race? Is it leveling the playing field or just changing the rules of the game?